Everybody, welcome back to another live stream from Scalar Learning. Last we saw each other, I was powering through a week-long session of SAT math problems from real SATs to get you ready for the December 1st SAT. For those of you who have taken it and are going to take it again, welcome back. And we got more content coming your way continuously every week. For those of you who are new to the channel, welcome. This is your #1 resource for all things related to math, but especially for SAT math to get you ready to rock out that test. And you know that you can count on the Scalar Learning channel for a weekly cram session right before your SAT date. So the next one will be in March to line up with that next SAT administration date. But I digress. Today we are back with more Khan Academy SAT problems, and we're tackling quadratic equations, which I really like, so I'm kind of excited. And if you haven't done so yet, make sure to hit that subscribe button so you can follow along with all the good math info we have here. And if you like the video that you are watching now, click that like button. Helps me out massively. I would really appreciate it. Okay, without further ado, let's jump in, and we're going to do a quick sound check here, and we're good. All right, let's begin. Solving quadratic equations. Now, as per usual, if you are new to the channel, you may not know this, but I never look at the problems ahead of time. I'm doing them live on camera with you so that you can really see the analytical process in real time, and that seems to be super effective for a lot of my students. So here we go. If b equals s and b equals t are solutions to the equation above, what is the value of s times t? Okay, a little bit confusing. What they're basically asking is find the two solutions to this equation and then then multiply them together. Okay, so what I usually say in a question like this is don't even think, just figure out how you can isolate b, right? This s and t is a little confusing, but let's isolate t and it'll make more sense here. Hold on, let me zoom in a little bit. Okay, so we got negative b equals negative 12/8. Oh, that's b squared. 12/8 minus b. Now, I'm going to divide both sides by negative, and we get a positive, okay? And then we've got 12/8. We don't need those parentheses anymore, equals b squared. Now, look, this looks like a nice quadratic that's factorable. I'm going to move these guys over to this side, so I'm going to add b to both sides, and I'm going to subtract 12/8 from both sides. And now we've got a pretty nice quadratic that we can factor. And this is really, 3/2, b squared plus b minus 3/2. Now, if you don't want to deal with a fraction or an improper fraction, I could multiply everything by 2, because this is all equal to 0 now. I could multiply everything by 2. Then you'll have a coefficient here. I think this makes the most sense if we leave it like this on. Let me think for a second. Because we'll have 1/2 and 3. 1/2, hold on, I'm trying to think. It's 3. I'm actually having a little trouble thinking about, 1 and 3/2. Thinking about how to break this up and make it factorable. So what I am actually going to do is I am going to multiply everything by 2. And we'll have 0 equals 2b squared plus 2b minus 3. So I'm just kind of thinking on my feet. Now we'll try and factor this. There is a method called the star method. We probably don't need it here, but I'll show it to you anyways. Assuming this guy is factorable, which I assume it is. The a terms go here and here, which is 2, right? That's my a term. That's my b term and my c term. My b term goes down here, 2. And my a times c, which is 2 and -3, -6, goes up here. Now we think about what numbers multiply to give us -6 and add to give us -2. Make sure I did this right here. Let me think. So we can have 2 and 3, 6 and 1, 1 and 6. Oh, maybe it's not factorable because we have 2 times 3, and that doesn't have a difference of -1, 1 and 6, no. Okay, I'm starting to think that this isn't factorable. So let's go back to the drawing board. When we're in this situation, we can always go to the quadratic. So let's take this as negative b, which is -2, plus or minus the square root of, and make sure I didn't make any mistakes here with the way I wrote it down, b squared, and that's 3/2 minus b plus b right? Minus 3 over 2. Okay, negative b plus or minus the square root of b squared, which is 4. 2 squared is 4. Minus 4 times a, 2 times c, which is negative 3, over 2 times a, which is, a is 2, so it's 4. So we got negative 2 plus or minus the square root of this is 4. This becomes negative, negative, positive, so 8, 24. 8, 20, so 4 plus 24, which is 28. 28 over 4. This can be, we can kind of pull a 4 out of that 28. So it becomes negative 2 times, or plus or minus 2 times what's left in there is the square root of 7, right? Because that's 4 times 7, and 4 is a perfect square, so that comes out as a 2 over 4. Divide everything by 2, and we get negative 1 plus or minus square root of 7 over 2. Okay, so these are my two solutions. Like S is negative 1 plus square root 7 over 2. T is negative 1 minus square root of 7 over 2. And now we have to multiply them together. This is a pretty hard problem. Honestly, never seen anything this hard on the real SAT. But these level 4 problems are usually tougher than what you'll get on the real deal. Negative 1 minus. I'm wondering if there is a shortcut to what I'm doing, but I think this is how you have to do it. Now we're going to multiply across. So negative 1. So on the numerator, we get negative 1. Let's move this up. Negative 1 times negative 1 is 1. Negative 1 times that is positive square root 7. Square root 7 times negative 1 is negative square root 7. And then square root 7 times square root 7, negative is negative 7. These cancel out. On the bottom, we have 4. So then we have 1 minus 7 over 4. 1 minus 7 is negative 6 over 4, which is negative 3 over 2. So I guess it is A. Oops. Yeah, I'm really not sure how to do that any quicker. It's really tricky. Let's make sure we got it right, first of all. We got it right. And I'll just look at their answers here, if there's any shortcut. Now that we have the constants term, we conclude that... So they jumped straight to the fact that the constant is the two solutions multiplied against each other. I wonder why that is. ST. That's a little oh man, I get it. That's a stretch though, because I wouldn't have figured that out. Basically what they're saying is when you factor this, even though it's not factorable, right? When you factor this, it's going to be whatever b minus, like whatever the solution is. Let's say A, let's call it S. And it'll be b minus t, right? And so if we want to know what s times t is, it's the final term. When we'd refoil this, it would be b squared minus bt minus bs plus st. So whatever this constant is out here is the same as this constant right there, and that's why it's negative 3 over 2. It's a pretty tricky one. I mean, that wasn't my first instinct. I would have probably done it the way that I did it on the real test, which was time-consuming but doable. Really hard one. Okay, next. In the equation above, k is a constant. For what value of k does the equation have no real solutions? Okay, this is what's it called? What's the term? I can't remember. The value under the square root, and I'm blanking on it. Oh boy, I can't remember. Okay, well anyways, look, when we have the quadratic formula, it's negative b plus or minus square root of b squared over 2a. So when this quadratic has no solution, it's when this value under here is negative. It's less than 0. That's when it has no real solutions, because essentially what you're saying then is we're going to have to take the square root of a negative. And if you take the square root of a negative, you're not talking about imaginary numbers, hence no real solutions. So all we have to do is figure out for what value of k will this be negative. So we can say b squared minus 4ac is less than 0, okay? That's when this will have no real solutions. Now we can plug these values in for b, a, and c. So b is sorry, b squared is, the b is 4, so 4 squared minus 4. A is 3, it's that value right here. And then c is k, is less than 0. So then this is 16 minus 12, k. Now let's isolate k. Negative 12k is less than negative 16. Divide by negative 12, divide by negative 12. Flip the inequality. K is greater than, this is 4/3. So whenever k is bigger than 4/3, we're going to have no solution. So negative 4/3 is going to be okay. Positive 4/3 actually should be okay because it's got to be bigger than 4/3. Negative 5/3 is fine. And here's the issue. 5/3, it's a value that's bigger than 4/3. Therefore, it would make this value here negative, which would mean we'd have no real solutions. Oh. Wait, did I flip that wrong? Oh, I made a mistake. Hold on. So the discriminant, that's the term I was thinking about. B squared minus 4ac. I must have flipped a sign wrong. Hold on. No, negative 16 minus 4ac. Let me see what I did. Oh, shoot. This value was negative. That's where I messed up. So the k was actually negative, minus k, so negative. So this was positive. Darn it, little mistake. So we don't flip the inequality. And then it was less than negative 4/3. So the only value that's less than negative 4/3 was negative 5/3, not positive 5/3. So a little mistake there. And you can see they probably did it that way. Yeah. So k is less than negative 4/3, and there we go. Okay. So mind those minuses. That can trip you up. That just tripped me up. All right, next. What are the solutions to the equation above? Now, a really nice thing here is we got fractions, but we don't need to have fractions. I can multiply everything by the least common multiple of 2, 6, and 3 of the denominators, and we don't have to deal with these fractions. It'll be a lot easier. So I'm going to multiply everything by 6. And the thing is, this is equal to 0, so I'll multiply this side by 6 too, but 6 times 0 is 0. So 6 times a half is 3. X squared minus 6 times 1/6 is 1x minus 2 equals 0. We don't need that 1. Now we can try and factor. Again, we'll use the star method. I assume this is factorable. If not, we'll use quadratic formula. So this is 3, 3. And remember, this is b is down here, which is negative 1. And here is a times c. 3 times negative 2, which is negative 6. What multiplies to negative 6 and adds to negative 1? That would be negative 3 and positive 2. And then we reduce these like fractions. 3 over negative 3 is 1 over negative 1. Now, these are my x terms right here, and these are my constants. So what I mean is, now when we factor, it's 3x plus 2. Okay. That goes there, and this guy goes here. And then over here, the same thing. The top is 1x, boom, minus 1 right there. Okay, equals 0. And where do these go to 0? Well, this goes to 0 when x equals 1 or when x equals negative 2/3. And those are my two solutions, right? Because negative 2/3 here will make this guy go to 0. Wow, these are some intense ones. So hopefully I've done this correctly because these make me think otherwise. But I think those are just to throw you off, and we're good. Yeah, it's pretty good. If you didn't multiply those out and get rid of the fractions, it's doable. It's just very messy, very messy. And you probably have to use the quadratic formula. Next. C is constant. The equation has solutions at t equals 3 over 2 and t equals negative 7 over 2. What is the value of C? Here's my thought. Straight away, I'm going to go, these are really hard questions. I'm going to go straight to this, and I'm going to say it's got a solution at negative 3 over 2. So t, if I factor it, it'd be t minus 3 over 2 times t plus 7 over 2. I'm just literally plugging these solutions in to factored form, and it would look like this. Now what I'll do is, again, I'm just thinking off the cuff, but now what I can do is I can FOIL this and somehow get it equal, eventually try and get it equal to this, to a t plus 1 squared plus a constant. So let's FOIL this. So we get t squared plus 7 over 2t minus 3 over 2t, right? So this there, then this there, and then that there. Negative 21 over 4 equals 0. These guys combined. 7 minus 3 is 4 over 2, which reduces to 2. So t squared plus 2t minus 21 over 4 equals 0. All right, now we want to sort of complete the square a bit. So look, I can see right here that I can get t plus 1 squared if I complete the square, meaning I take half of this term and square it. So I get t squared plus 2t plus 1. Half of 2 is 1, 1 squared is 1. And I like this because this is that perfect square of t plus 1 squared. So let's leave that equals or minus 21 over 4. But wait a minute. I can't just add a 1 and think everything's going to be okay. I need to balance this out. So I have to add a 1 to the other side, or I can subtract 1 outside of the parentheses from this side equals 0. Now I've added a 1 and subtracted a 1, so I haven't changed the equation. Now this can be factored into t plus 1 squared. These can be combined into, this is negative 4 over 4, right? Same as 1. Minus 25 over 4 equals 0. All right. And you can now see, look how nice this looks. We got t plus 1 squared just like here, and our c is clearly negative 25 over 4. Let's make sure that exists, and that looks good to me. All right, excellent. Question number 5. In the equation above, k is a constant. The equation has solutions 7 and negative 2. What is the value of k? All right. So again, it's giving us these solutions, and I'm going to plug it straight into factored form. That means this should factor to x minus 7, x plus 2. Okay, and this theoretically should equal x squared plus kx minus 14. And here's the deal, right? Because this also equals 0. If I just FOIL this, I'll figure out what k is. I could try and factor this and go backwards, kind of a pain, but this is much easier to go forward. So let's go FOIL x squared plus 2x minus 7x minus 14. Combine like terms, x squared minus 5x minus 14. And guess what? My k is right here, right? Which is, don't forget the minus in front of it, negative 5. What I always say is that sign to the left belongs to the number. So it's a minus in front of it. It's a negative 5, not a positive 5. And there we go. All right, that is it for today's topic. Again, if you found this video helpful, please click that like button and make sure to subscribe if you want to see more math content and math information coming your way from Scalar Learning. And guys, thank you so much. You'll see a new live stream next week on SAT material, and we're still getting the schedule sorted out for a ton of new content. We're going to be covering ACT stuff, SAT stuff, and of course, IC stuff, which is the Independent School Entrance Exam. So make sure to stay tuned for that. New schedule's rolling out in December. It's just been crazy busy for me on the tutoring side, but it is happening. So that is it for today's live stream. Have a great Friday and an amazing weekend, and I'll see you guys next time.